Welcome back. I'm Liz, and I'll be your instructor in this second chapter. Here, we'll talk about cloud in practice, beginning with cloud deployment models. Choosing a cloud deployment model is one of the first choices to make when migrating to the cloud. It's informed by how much control you need over your cloud environment, which is defined by your business requirements and budget. There are several models, but the most common are public, private, and hybrid. Let's go through each of them and understand their unique value. The private cloud is private by design and designated for exclusive use by its tenants. This means to access a private cloud, you need to connect to a network link, which means special network access needs to be set up by IT. An organization may hire a third party to host their private cloud infrastructure or host it themselves. The private cloud model can be appealing because infrastructure is designed for exclusive use. This gives an organization direct control over the resources available alongside with how data is stored. For example, you can specify what kind of operating system and the exact hardware you want. This is flexibility that does not come with other models. This is especially useful if there are specific security requirements or risks. But it usually requires more investment in terms of time and capital expenditure compared to the other models. Consider the infrastructure that needs to be designed, the hardware that needs to be bought, set up, and maintained. However, this decreases if a third party like IBM or Rackspace provides and maintains the hardware. You may be wondering how this is different from on-premise. If so, good question. The infrastructure in this model adheres to cloud principles, meaning it uses virtualization that allows on-demand compute resources. Private cloud can also be located off-premises. The second model is the public cloud. The cloud infrastructure is shared and open for use by the general public. The infrastructure is owned and managed by a cloud service provider like AWS or Azure. Public clouds are internet accessible. This lets organizations get started quickly with minimal investment. They don't have to host or commit to an infrastructure. Instead, they can pick what services they need from a provider. They can also instantly buy more capacity, making it easier to scale. If it's important to have direct access to the data centers or hardware, then public cloud is not a good choice. Public cloud providers keep their data center locations secret, even to their clients, for security reasons. Why not both? Enter the third model, hybrid. This is when an organization uses a combination of two or more distinct models. The different models interact with each other via a network link and can share data and services. It's more of a question of where data and services are physically stored. For example, you could store sensitive patient data on a private cloud for security reasons and use an application on the public cloud like a business intelligence tool to process it. Hybrid clouds are useful in the case of cloud bursting. This is when a private cloud is overwhelmed by demand and hits capacity. To avoid disruption of service to users, traffic is moved to a public cloud instance. A classic example of this are seasonal spikes. For example, retail businesses can expect extraordinary traffic during sales periods like Black Friday or Boxing Day. This allows organizations to cost-effectively handle periodic spikes with pay-per-use pricing. There are other cloud deployment models to consider, including multi-cloud. Multi-cloud combines different cloud provider services. For example, an organization could use Azure for backups, AWS for web hosting, and Google Cloud for analytics. Multi-cloud provides flexibility on choosing pricing plans and service offerings. It also reduces reliances on one vendor. Don't confuse this with the hybrid model, which uses a combination of cloud deployment models, not services. Another model to consider is the community model. This is when the cloud's infrastructure is shared by a specific community for their exclusive use. Usually this community has a shared interest or concern, whether it's having the same security requirements or jurisdiction or sharing a mission. This shared infrastructure allows for easier collaboration and sharing of data, whether it's research data between institutions or government data across agencies. The infrastructure itself can be managed and hosted internally or externally. All right, let's check your understanding. Nice job on those exercises. In this video, we'll talk about the way local regulations and laws can affect an organization's cloud infrastructure. Let's begin with an example. Imagine a fictional social media company founded and based in the US. They started with a data center in the US, but as they grow their user base to international audiences, they add a data center in Europe and another one in South America, and eventually one in Africa and one in Asia. Having servers spread out across the globe reduces latency. The greater the distance between 2 points, the longer it will take for data to get there. This delay between the moment data is transmitted and the moment it is received is known as latency. Having servers spread out across the globe reduces latency. This means that when someone accesses their account in Australia, their request will be sent to the nearest server, rather than a server in the US or South America. Let's say this Australian user just signed up for an account at this fictional social media company. That means her personal data was just sent outside of the borders of Australia. And here's where it can get tricky. Australia has regulations on how data should be processed and stored, and there will be regulations on data wherever the data center is in Asia. And finally, the company will have another set of regulations it needs to follow in its home country. An example of data privacy law is the European Union's General Data Protection Regulation, or GDPR. And that's a good example of the type of regulation I'm talking about, because it regulates how personal data is collected, processed, and stored from users in the European Union. For example, before a company collects any data, they need to explicitly get consent. Companies also need to notify users of any data breaches in a timely manner. Personally identifiable information must be encrypted, anonymized, and/or pseudonymized when stored, depending on the scenario. And some regulations affect how data can be physically moved. For example, personal data can't leave EU borders unless the company can guarantee that the data will have the same level of protection wherever it may land outside of the EU. Can you see how this affects cloud computing, where data moves through different servers around the world? There's major incentive to comply to GDPR. The fine can be up to 20 million euros or 4% of the company's worldwide annual revenue, whichever is greater. A lot of these regulations talk about personal data. What does that mean exactly? The European Commission defines it as any information that relates to an identified or identifiable living individual. Different pieces of information, which collected together can lead to the identification of a particular person, also constitutes personal data. This includes home address, first name, last name, email address, location data, IP address, racial or ethnic origin, political opinions, sexual orientation, and health-related data. Some of these on their own may not identify a specific individual, but for example, if you combine all the location data of a given person, it can get much easier to identify who they are by where they spend the most time, like their home address. Personal data is often referred to as PII, which stands for Personally Identifiable Information. GDPR is the most known data protection regulation because of its massive impact. Several countries followed suit to comply with aspects of GDPR so that data could more easily flow between borders. Here are a couple other data protection laws, new and old, from other parts of the world, including Brazil, the United States, Japan, Thailand, and Canada. We can't go through each regulation in detail. The point is that it's crucial to check local regulation. Protocols may be different country to country and can influence where companies choose to set up their data centers. Let's check your understanding. Hello! To wrap up this chapter, we'll take a look at cloud computing roles. In previous videos, you learned how cloud adoption can reduce maintenance and operational costs, including personnel. While that's true, the rush to adopt cloud computing has created a huge demand for cloud-related skills in the job market. The employment search engine, Indeed, listed cloud computing as the most in-demand skill in February of 2020. LinkedIn has it listed as the second hard skill companies need most after blockchain. This means cloud computing skills are ranked as more in demand than artificial intelligence and machine learning skills. In fact, all the major cloud providers have established certifications for different cloud skills and roles, specific to their cloud platform and services. These are viewed as very valuable in today's job market. Familiar data roles like data scientists, machine learning scientists, data engineers, and data analysts can all benefit from learning about the cloud. For example, data scientists can benefit from running computationally expensive analyses on the cloud, which not only saves on costs, but also reduces the time it takes to run because of the vast computation power available on the cloud. Machine learning scientists can train and deploy machine learning models on the cloud. This is something that's typically computationally expensive, especially when we're talking about deep learning. It's standard now for data engineers to be proficient on the cloud. Data engineers build pipelines on the cloud to ingest, transform, and store big data securely and efficiently. Even less technical roles, such as a data analyst, can be expected to know how to access data from the cloud via business intelligence tools like Tableau or Power BI. Generally, having analyses in the cloud makes it easier for teams to collaborate because you aren't passing files from one machine to the next. Additionally, the rise of cloud computing has also created new job titles, notably cloud architect and cloud engineer. It has also increased the need for roles like DevOps engineer and security engineer. Let's go through each briefly to understand how they work to make the cloud possible in an organization. As you will see, there's often overlap in how these growing roles are defined. A cloud architect is a solutions architect, essentially, for the cloud. A cloud architect takes the technical requirements of a business problem, designs an appropriate cloud infrastructure, and comes up with a plan to deploy said infrastructure. They have to ensure that their design is scalable and optimized for cost. Cloud engineers build, maintain, and monitor cloud services. They are often responsible for migrating on-premise solutions to the cloud. This title is often used as a catch-all for any technical work required on the cloud. For example, in smaller companies, the cloud architect and engineer can be one role. DevOps combines software development and IT operations. Previously, there were system engineers who maintained server infrastructure by physically configuring hardware. Now we do that by code, which is the developer aspect of DevOps. DevOps engineers ensure the reliability, availability, and scalability of the cloud through software development and automation. For example, if there's a rise in usage, there should be some automation to increase resources, or if a server shuts down unexpectedly, there should be an automatic patch and redeploy. As we discussed in the last video, security is very important on the cloud and requires different technical requirements depending on the geographic area. Security engineers spec the technical security requirements of an organization's cloud infrastructure. They work to test and assess the security of data on the cloud. Generally, they are responsible for protecting organization and user data from a technical perspective. The adoption of the cloud has defined new roles and created new skills for existing roles. Now it's time to wrap up the chapter with some practice.